Hello, my name's Jeremy Shooks. I'm a design and manufacturing application engineer at Applied CAX. Today, I'm going to give you a little demo on how to use the analysis tool check wall thickness. We're going to focus on the rolling ball method. Now, what the rolling ball method is, or how it works, is if you could imagine a balloon that is inflated within the walls of a solid object. The balloon is then inflated until it no longer makes a perfect sphere, and at that point it'll record the diameter as the thickness in that location. So to kind of give you a little more understanding of that is we have this example file here, this example part. As I move my cursor around in this object here, you can see that the balloon or the sphere actually changes sizes as the walls change in thickness in those locations. And if I was to stop and say this location here, you can see that the thickness value, it'll give you a value for the thickness, which correlates to the chart over to the right. As we move down to say here, the default thickness of this part was 3 millimeters, and it shows up as 3 millimeters as the thickness there. I guess another way to look at it is we have these two different spheres here, and the one on the bottom here, this magenta colored one, is actually inflated until it hit actually three surfaces here. It hit this radius here, and this bottom face. But this top sphere up here did not have to hit in three spaces before it could no longer be a perfect sphere. So it's not always three faces that it has to hit to constrain it. It could be less than three. So that's kind of how that part of it works. Moving on with the demo, I was going to show you how you could use this in plastic injection molded part. So in this scenario here, we have the side of a tool here, and the nominal wall stock is 3 millimeters. So we're going to run the analysis tool on here to see if we have any issues with the ribs or anything else in this file. So how you do that is under the analysis menu. If you scroll over to the right, you'll see this one here that says check wall thickness. We'll go ahead and go inside of this application here. And what I tend to do is set the maximum spacing to the nominal thickness of the part. That seems to be a good starting point. And we'll do rolling ball, so make sure that's checked at rolling ball. Once we have these values queued in up there, we'll actually click this calculate thickness icon here. And this part here shouldn't take that long to run. Once it's done running, you can see that it's changed colors, and we have this chart over here. What I like to do is try and make it a little more meaningful by setting it up to be like percentages of the actual thickness of the part. So in this example, it was 3 millimeters, so we'll work our way slightly bigger than, we'll go like 10% above 3, and then work our way down all the way to 0. If you notice, after I typed in the first number here, we get this error message here, or this alert. You can ignore that, because once we're done filling out this chart, that'll go away. It's just telling you that this number over here is smaller than this number, and the way this chart works, you can't have those numbers. This number bigger than the small number on the column above it. So let me go through and finish queuing in the values for this demo. And then in this example here, we're going to assume that anything under 1 is too thin, so we won't go any lower than that. The next thing I like to do is go through and define some colors here that are a little more meaningful, or a good contrast difference between them. So once we have that filled out, we can go ahead and apply down here. And then before I go any further, what I like to do is go back over to the calculate tab, hit save, and then hit OK to exit. You're not actually, this isn't actually, the results are not actually saved until you actually exit the application here. So we'll go ahead and hit OK to exit it. If you notice, once I did that, we get this new analysis folder here on the part navigator tree. And if we go within the inside of this, we can see we now have our analysis. This is the analysis that we just ran. So we can double click on this to review the results. So one of the things we can look at is under the overall results here, it'll actually tell you the maximum thickness. So the maximum thickness in this part is 9.09. The other thing I like to do is to, spin it around here. And if we look at this side, any of those magenta areas are areas that I would like to have a little focus on because they are quite a bit thicker than the nominal wall stock of 3 millimeters. They're above the 3.3. So what I tend to do is flip around, look at the other side of the wall, and we can see that this rib here gets really thick. It's over the nominal wall stock thickness, and in plastic parts, anywhere that you have something that it usually exceeds 50 or 60%, it could start causing surface issues on the part. It might create sinks or blemishes in those areas. So after reviewing the part and looking at the problem areas, what we can do is go ahead and OK out of this, and then we'll make the changes to the part and then run the analysis again, and I can show you how that's done. So once we have all the changes made to the part that we've seen in the prior slide, we can go ahead and run the analysis tool again. And how you do that is we can actually just go into the one that we previously created, click on it, make it active. And if we look at it now, it's still showing these areas are thick. That's because this tool has to be ran anytime you make a change. It just saves the results from the last run. So go ahead and click on calculate thickness again and let it run. So now if we look at the part, we can see it looks a lot better than it did earlier. We don't have as many of those ribs bleeding through. We still do have a couple problem areas here though where those screw bosses are. And then if we flip it around here, we can see that we have some gray areas where it's getting a little too thin. And if we look at this area here, you can see where it goes from gray to this dark green. If it was a Class A surface, that would be too steep of a transition, and you'd want to do something to remedy that. But since this is the B side, it's not that big an issue. The only issue is that it's too thin up here, so we would have to add thickness to that. Some of the other tools that are useful in this would be under the range tab. You can set the high limit to, so if you just wanted to see areas that were 1 millimeter and less, so like thin areas, you can set this to 1 and then hit apply. And now it'll just show you the areas that are thin. So you can see this area here is super thin, and then this area over here were the only two areas that were thin. Likewise, you could do the opposite. You could just look at stuff that was say thicker than 3.5 millimeters. So you could put 3.5 for the low limit, and then we'll do 10 for the high limit. And then once you hit apply, you can see where all your thick areas are now. Everything else is kind of hidden or set translucent. The other feature that's useful in this command would be if you wanted to know what the specific values are at certain points, you would go back over to the options tab. So if you did want to save the value at that location and you wanted to save the sphere that created it, you would create these two checks here. And now we'll go to the inspect tab, and then under this dynamic thickness display. We'll click on this, and if you notice, as I move this around, you can see that the thickness value is changing, but we can't really see. Let me zoom in. You can't really see the sphere that it's creating. So what I tend to do when I'm trying to do this part is, if you were to turn off all faces here and use the slider here, the slider actually tells it, you know, how much of that, or the translucency of the actual solid body. And then whenever you go move around the part, you can actually see the sphere. So say we wanted to know how thick it did actually get over in this area here, we can actually move this around, and as moving around you can see the number gets bigger. And then once I click, it'll actually save that sphere, and if you notice, it actually created some text to go along with it, telling you the exact location and the thickness at that point. And you can, you know, put these anywhere you want, as many places as you want, and it'll save that value. And then once we OK out of this, you will see that they're still there. So they're actually not part of the wall thickness analysis anymore. They're actually separate from that. And if you look at your model tree, we actually have these different spheres that it creates in the model tree. So that's how you can use the check wall thickness to validate molded parts, plastic molded parts. Thanks for your time.